Good day, students. How's been your day? How are you doing? Now, for the topic under motion, we are moving to the subtopic distance time graph. The distance time graph is an idea which can be illustrated using a moving couch, that is a bus which travels from certain points A to C. From the graph below that you can observe, at point A, the graph slopes up gently. The bus is traveling at a low speed. At point B, the graph becomes steeper. The distance of the couch from the starting point has increased more rapidly. It is moving faster. At C, graph is flat. Distance of the couch from the starting point does not change. It is static. The distance time graph explains how the couch is moving. So the summary of the distance graph is displayed below. For the first 5 minutes, that is at point A. For the next 10 minutes, that is at point B. And after the 15 minutes, the speed of the bus remains all the same at C. So let's look at express trains and slow buses and do some activity based on that. An express train is capable of reaching, let's see, high speeds, more than 300 km per hour. When it embarks on a journey, it takes a while to speed up, that is, accelerate, and slow down, that is, to decelerate. Let's check. That is it. A bus journey is full of acceleration and deceleration. The driver of the bus hopes to move at a steady speed. The steady speed creates comfortability. When there is deceleration, the bus comes to a halt, that is, to a stop. From the bus, rapid acceleration and deceleration means that the passengers feel the movement of the bus at its changes speed. Check. Correct. Now, activity. Average speed is defined as the total distance traveled per unit time, measured in kilometers per hour. Is that true or false? Let's take true. Check. So a runner travels 400 meters in 50 seconds. What is the average speed? Don't forget that from our last class, we discussed about average speed. And average speed is the total distance traveled per unit time. So if I should have average speed now, I have distance over time. And that gives the distance now is 400 meters divided by 50 seconds. So what's the answer now? We have 8 meters per second. Would that be the answer? That is it. Activity 2. A bus is traveling along a road. It is traveling a distance of 400 meters in 25 seconds. What is the speed of the bus? Just like what we've done before, Speed is distance over time. And distance here is 400 meters, all divided by 25 seconds. So we have 16 meters per seconds. Is it part of the option? Correct. Now, a child is standing on the platform of a station, watching three trains coupled together. A train traveling at 30 meters per second takes 3 seconds to pass the child. What is the length of the train? Now, three trains are coupled together, and one train is traveling at 30 meters per second. That is the speed. And three of the trains are together. We are now asked to determine the length of the train. And it takes time of 3 seconds. What we have to do is to calculate the distance moved by one of the trains and then multiply the distance by 3 since we have 3 trains coupled together. So distance now is speed times time, and that is 30 times 3. That will be meters. Distance is 90 meters for one train. One train. So for the 3 trains, that's 3 times 90 meters. That's 270 meters. Do we have it as an option? Let's see. That is it. Now, activity 3. The tunnel has a length of 50 kilometers. A car takes 20 minutes to travel between the two ends of the tunnel, that is from the start to the stop. What is the average speed of the car? Here now we have distance to be 50 kilometers and time is 20 minutes. So we have to calculate the average speed. Speed is distance over time. We have 50 kilometers, and for 20 minutes, don't forget that 60 minutes is equivalent to 1 hour. 20 minutes will be 1 over 60 times 20. That's 1/12, 1 over 3 hours. With that speed, now be 50 kilometers divided by 1 over 3 hours. Speed now gives us 50 times 3, and that's 150 kilometers per hour. Do we have it in the option? That is it. Now, looking at this figure, where we have speed meter, which is measured in meter per seconds on the vertical, and time, which is measured on the second in seconds on the horizontal. The diagram above shows the speed time graph for an object moving at constant speed. That is, the speed is not changing. What is the distance traveled by the object in the first 3 seconds? We can see that the origin is from 0, moving down to 3 seconds and to 2 meters per second. So with that in mind, the distance now will be speed. The distance now will be speed. Distance will be speed times time. Since distance was obtained from speed is equal to distance over time, distance now becomes, that's 2 meters per second times time, which is 2 seconds, and times time, which is 3 seconds rather. That will be 6 meters. So from the options, let's check. Let's check. So moving on, a car accelerates from traffic lights. The graph shows the car's speed changes with time. How far does the car travel before it reaches a steady speed? Knowing fully well that the speed we have is 20 meters per second, and the time for the whole journey is 10 seconds. Now we are dealing with distance. That is, how far does the car travel? That will be speed times time. That will be 20 meters per second times 10 seconds, and that will give 200. Would that be so? 200 meters. That is it. Now, to the summary of all what we have done. From my explanation on the first page, dealing with the couch that is moving from point A, B, and C. Now, we have to choose the correct statement. The slope of a velocity time graph shows us how fast an object is in a state of rest. No, an object in a state of rest will not move. The slope of a distance time graph shows us how fast an object is moving, and that be true. That will be dealing with speed, and speed is what? Distance per unit time. The slope of a displacement time graph shows us how fast an object is moving. Displacement with time relates with velocity, so that can be true. So the slope of a distance time graph shows us how fast an object is moving. Can we check? All right. Do well to join us for more interactive notes from www.edubbey.com. You can also subscribe to all our classes which are online. Do have a great time. Thank you for listening.